Okay, now we have got a new instance created for our cluster. Previously we were using T2 micro and it was giving us the issues in getting getting the communication established between the kubectl and that cluster, because that T2 micro doesn't have the enough resources to run the microcats cluster. So then we have created a new instance which is T2 large, so which is in terms of resources it is big in terms of resources. So it has got a 4 GB RAM and 4 virtual CPUs. So that's what we have created. We have installed microcats as we had already done. So we have already done those steps, those same steps we have performed, and we have got the microcats cluster created. Now we have also created a YAML file to create the deployment. Now we are going to create that deployment. So can you please open this YAML file maybe in the notepad? Rameshri, can you just show that YAML file once? Correct. Now let's do the changes here. Let's that containers, do you see that word containers? Just get that one indent inside towards the right, the word containers. Yes, just let's get that inside, one indent inside. Correct. Let's get this. There should be one dash instead of two, exactly, and then this exactly. So this is how the indentation of our YAML should be. So we have here the deployment of the Nginx server. So this Nginx server deployment is going to start the pod, and that pod is going to have one container, and that container is going to run a Nginx image, right? And it is going to listen on port 80 inside the container. So this deployment YAML we have now. Now we are going to create this deployment or execute this deployment. So let's go to that instance. So that same file we have here in this directory. Can you just do clear? Just let's clear the screen. Yes, let's check the contents of this folder. Yes, so here we have that same file. Okay, so here we have that same file, and now we are going to create the deployment based on this YAML file. So let's come out of this file. Let's do Control X just to come out of this. Correct. And now let's run a command. There is a command kubectl apply. Okay, so what this kubectl apply does, so this kubectl apply creates the Kubernetes resources which are defined in a particular file. So kubectl apply, so our command is kubectl apply, then we are saying -f. So -f is for telling it which YAML file to refer to, and it will refer to this YAML file, Nginx YAML, and it will create the resources defined in this YAML. So in this file we have defined a deployment resource, and that deployment resource is going to create a pod, and that pod is going to run one container, which in turn going to run Nginx server. So let's hit enter. So we can see there is a message called deployment created. Now it has created the deployment. Now how to check? How to check if the deployment has got created fine or not, if the pods are have got created fine or not. So let's run the commands now. kubectl space get space deployment. Exactly, enter. Now we can see here Nginx -deployment. Now can you go to that YAML file on the notepad? You can show us the YAML file. Exactly. Now do you see on the line number 4, 1 2 3 4, exactly, the name Nginx-deployment. This is the name which we can see there when we are checking for the running deployments. Now go to that EC2 instance screen. Correct. So here we can see Nginx deployment. right? And in the second column we can see 1/1 ready 1/1. So it means that there are going to be one replica of the pod, one pod we have, which is being controlled by this deployment. So deployment basically controls the pods, and pods runs the containers. That is how it is. Okay, now let's check out the pods. So we can check the pods also. Now let's run the command kubectl get pods. Instead of deployment, let's say pods. Enter. Now we can see here there is one pod running, nginx dash deployment. This name is the one which this name is the same as the name of the deployment. And after that we can see some arbitrary string. So this particular string is a dynamic string which gets auto generated, and our deployment name gets this auto generated string concatenated, and this is how we get the name of the pod. Then we can see in the second column we can see 1/1. So what does it mean 1/1? That in this pod we have one container, and out of those one container, out of one is running. You may have multiple containers in single pod. You may have multiple containers in single pod. Please understand what I'm saying. Multiple containers can also be executed inside a single pod. Okay, but let's say if you have two containers in a single pod, so here you will see 2/2, meaning out of two are running. Then the status, the third column is status running. It shows us the status of the pod, right? And age, the last column age shows us like since when this pod is in this running state. So it's in this running state since last 115 seconds. Okay, now this is how we can check the pods. Now let's check the logs of the pod, the way we used to see the logs of the container, right? So we can see the logs of the pod as well. Now let's run the command kubectl.
I just have one question. So this says that one container in one pod, right? So
no. It says that out of one container in that pod, one is running. Out of one is running. Let's say if you have 3. So initially, like what will happen is like once the pod would be created, the containers inside that pod will start getting created. Okay. So for some time you will see that out of 3, 1 is running, and the rest of the 2 are yet in the creation phase.
Okay.
After some time you will see out of 3, 2 are running. Okay, the third one might be in the creation state, and after some time then ultimately you will see that 3 of 3 are running. So all the 3 containers from that pod, they are running now. That is how it is. Okay, so it shows you the state of all the containers inside that pod. Okay, now let's check the logs. So command is kubectl logs space the name of the pod. Let's copy the name of the pod. I'll tell you how to copy. Just mark that name. Don't do Control-C. Simply mark it. And let's just right click on this line where we want that. Yes, paste. Okay, not a problem. Let's scroll down. Okay, we need to get Control-C. Just do Control-C simply. Okay, let's clear the screen. Let's see the list of the pods again. kubectl get pods. Okay, now let's run kubectl logs. And let's mark the name. let's right click, copy. Yes, let's paste it here, enter. Right, so these are the logs of that container, the Nginx pod which is running. Right, now currently we have one pod running, right?
Yeah.
Now we can have multiple replicas, as we had discussed in our earlier sessions, that if something goes bad with this. Now let's see that. Let's clear the console, and what we will do is we will delete this pod. We will simulate that something bad has happened with the pod. Okay, and I'll show you how the Kubernetes starts the new one in place of the existing.
Yeah.
Let's do kubectl get pods again. kubectl get pods, correct. Let's run a command, kubectl delete pod, pod space and then the name. So it will delete this pod. Enter. Correct. Now let's check kubectl get pods immediately. Let's check. Get pods. Yes. Now you can see in place of that, which got deleted, we have got this new one started, which is since last 9 seconds.
Yes.
Right. So Kubernetes starts the pods as soon as it detects that something bad has happened with it. Okay.
Yeah.
So this is how the self-healing works.
Okay.
So if there is any issue with the pod, it then starts the new one.
Okay.
Right, now just a second. Now okay, so we have got this. Okay, now there is another command. Let's run the command to delete this deployment. We can delete this deployment now. Let's run. Can you just get that apply command on the screen from the history?
Yeah.
So instead of apply, just mention delete. So it will delete the deployment. Correct. Now let's check the pods, get pods. Now there won't be anything. Now there is nothing, right? Because that entire deployment has been deleted now. Now what we can do is we can create the replicas of a Nginx server. So currently, like we just had one replica or one pod running the Nginx. That is what we had. Now we can have multiple replicas. Now just open this Nginx YAML file in Nano. Enter. Right, do you see there there is a line called replicas? Just scroll down. Yeah, just scroll down and just make that 3 instead of 1. Let's make it 3. Correct. Let's do Control X. Enter. Why enter? Correct. Now let's run apply. kubectl apply. Hit enter. Now let's check the get pods. Let's check the list of pods. Now you can see there are 3 pods running.
Yes.
Right. So instead of 1, we now have got 3.
Yeah.
So this is how you can start the replicas. So if one goes down, Kubernetes will definitely start a new one. There is no doubt about that. But by the time that new one starts and by the time it starts receiving the requests or accepting the request, the other two will serve your users.
Okay.
So there won't be any downtime
Yeah.
for your application. That is the concept. So self-healing we have got, we also have got high availability. Just that we do not have as yet, we do not have the high availability of node. Means if something goes, something bad happens with the node meaning the machine itself, then we do not have any fallback right as of now, because we have a single node cluster. Okay, but we can create multi-node cluster also. There is no doubt about it.
Yeah. So in that, if multi-node clusters are there, then let's say this nginx.yaml, we wanted to deploy it, right? So if there are multiple pods, we can put each container in different pods.
No. Anyways, each container runs in a different pod. But what will happen in that case is each pod will go to different node.
Okay.
Right now, we have these three nodes running, three pods running on a single node right now. Right? If we have multi-node cluster, let's say we have a cluster of 3 nodes, 3 machines. Okay. So one pod will go on one node, second pod will go on second node, third pod will go on third node. That way. Are you getting my point?
Okay.
So that is how the pods would be distributed amongst the node, so that even if one node goes down, what will happen is, like, if you have all the 3 pods running on a single node, and if that node goes down, then it would be a single point failure for your application, right?
Yes. So if there are multiple nodes, then the pods will be distributed amongst multiple nodes, right?
Exactly. So one pod would be on one, second would be on second, third would be on third. That way it would be.
But as of now, we are just having one node, so all these pods are belonging to.
I'll show you how can we check if on which node the pods are running. kubectl, just get that command, kubectl get pods space -o space -o space wide WIDE, enter. Yeah, do you see that? Just a second. These IPs are, it is showing you the IP of the node 172.31.55.127. Do you see that?
Yes.
So this is the IP of the machine where we have the microcates installed. So that is one of the node in our cluster.
Yeah.
Okay, so we have only one node as of now. But when we will create a multi-node cluster, then few pods would be scheduled on node 1, few of them would be scheduled on node 2, that way.
Okay.
Right?
Yes.
Perfect. Okay, great.